This is a series on the specifics of how neural networks work. The intention is to illustrate a little more explicitly and delve a little more deeply than most other series you might find on the topic on YouTube. I would recommend first you watch 3 Blue and Brown's series on neural networks. It serves as a great jumping off point for learning more. This video is about basic forepropagation. 3 Blue and Brown used an MNIST network as an introduction. Here I use a much smaller network, just about capable of mimicking a binary operation. We will train it to function as an exclusive OR gate. An XOR operation has one output with two classes, true and false. The two outputs of our network represent these classes. Output 1 being how much the network thinks the output is true, and output 2 being how much the network thinks the output is false. To train the network to mimic an XOR operation, we need to feed it the dataset of an XOR operation. In this dataset, we have the possible inputs along with their expected outputs. In this case, we can represent the outputs in two ways, as the expected outputs from the network or as the class labels, with label 1 representing true and label 0 representing false. In this small network, we have 2 neurons in our input layer, 3 neurons in our hidden layer, and 2 neurons in our output layer. The neurons in our input layer only contain a single value, their activations. This is represented by the A values. All neurons in our hidden layers and output layer have 3 values: their activation, the A's, their bias, the B's, and their input, the Z's. I'm using the input to mean the value of the neurons after the bias has been added, but before the activation function has been applied. We will see why this value is important later when covering backpropagation. Every neuron also has a weight value connecting it to every neuron in adjacent layers. The weights here are represented by the W's. In 3 Blue and Brown series, he avoids using matrix multiplication to make explanation easier. Here I will be using matrix multiplication. If you don't know what matrix multiplication is, pause this, go to the relevant links in the description, and then come back. I should also note that I won't be covering the proofs of equations in this video. They are the same equations as illustrated by 3 Blue and Brown, but using matrix multiplication. I expect you will find their application here straightforward, and I hope that by simply illustrating their specific functionality, they will become simple. With those points covered, we can begin forepropagation. We first select an input from our dataset and set the activations of our input neurons to that input. We then multiply the activations of our input neurons by the weights connecting our input neurons to the neurons in our hidden layer, and add the biases of the hidden layer. The resultant values are our Z values. We store these values. After this, we apply the activation function, in this case using the sigmoid function. The resultant values are the activations of our hidden layer. We store these values. At this point, we can simply repeat this process for however many layers remain in our network. In this case, we only need to repeat this once more for our output layer. If you understand what I just went over, you now have a real understanding which covers the precise values and operations of the process. Next episode, I will cover backpropagation. I would just like to add here that I apologise for all the ways this video is bad. This is my first ever YouTube video, so I just ask that you forgive some of the countless mistakes I've made and am going to make along the way. Thank you for watching.